Hey everyone, welcome back. Today we're diving into a groundbreaking study that's redefining how we understand student feedback in online education. Imagine this, you're taking an online class and the instructor is giving a lecture. But here's the problem. There's no eye contact, no body language, no subtle cues to tell if students are confused, bored, or really getting it. That's the reality for many learners in the digital classroom. This research from the University of Notre Dame is tackling that exact issue. The team wanted to bridge the gap between traditional classrooms and online learning by decoding student emotions through text. Their solution: sentiment analysis, a powerful tool that doesn't just read words but deciphers the emotions behind them. So how does this work? Let's break it down. Sentiment analysis is like teaching a computer to feel the tone of a sentence. Instead of just hearing what students say, it identifies whether their feedback is positive, negative, or neutral. Was that comment frustrated, excited, or indifferent? This is critical because, in a physical classroom, teachers pick up on these cues naturally. Online, that's where the gap starts. The researchers didn't stop at theory. They built a model to process real student feedback, starting with a massive dataset from sources like Rate My Professor. But raw data is messy. They cleaned it up, removed irrelevant noise, and used a technique called SMOTE to balance the dataset. Why? Because if most comments are positive, the model might overlook the negative ones, like a doctor missing a rare disease because they're focused on common symptoms. Next, they transformed text into numbers using TF-IDF, a method that highlights words that matter most. For example, boring or confusing get more weight than the or and. Then came the real tech magic, a deep learning model. This isn't just any model. It uses layers like word embeddings, which turn words into math-friendly vectors, LSTMs, a type of neural network that remembers context, and attention mechanisms, which let the model focus on the most important parts of a comment. They compared this to a simpler approach called logistic regression. Why? To see if the deep learning model was actually better at capturing nuance. And guess what? The deep learning model outperformed the baseline, proving it's better at catching the emotional subtleties of student feedback. The implications: imagine an online platform that doesn't just track grades, but senses when students are struggling. Teachers could get real-time insights into how their lessons are being received, allowing them to adjust and improve. It's like giving educators a superpower to connect with students, even when they're not in the same room. But how did the model perform? Let's look at the numbers. The LSTM model achieved 80% accuracy, versus 77% for logistic regression. It also scored higher in precision, avoiding false positives and recall, catching all real positives, with an F1 score of 84% versus 77%. The AU-CROC metric, which measures how well the model distinguishes between positive and negative feedback, was 0.88 for the LSTM versus 0.86 for the baseline. These aren't just numbers. They represent a more reliable, nuanced understanding of student emotions. And the model didn't just handle straightforward comments. It excelled at parsing tricky sentences like, "The lecture was not engaging but informative," or "The lecture was extremely engaging and incredibly informative." By focusing on keywords and context, it balanced conflicting sentiments with remarkable accuracy. This isn't just about technology. It's about making online education more human. By understanding the emotional undercurrents of student feedback, we can create better learning experiences for everyone. Now here's a twist. This research is part of a larger trend in AI. Take Nidhi Nurbhik's 2023 PhD dissertation, which explores how to detect extremist ideas in text. Her work uses similar techniques, like attention mechanisms and deep learning, to identify patterns that humans might miss. The same tools that help us understand student feedback can also flag harmful content online. So next time you're taking an online class, remember, behind the scenes, there might be a model working hard to make sure your voice is heard. Thanks for watching and stay curious. Want to dive deeper into how AI deciphers text? Let's explore the math behind it. When the model processes a sentence, it converts words into vectors, mathematical representations that capture meaning. For example, happy and joyful might end up close in this vector space. Then LSTMs process these vectors sequentially, remembering context as they go. Think of it like a reader who doesn't forget the setup of a joke when they reach the punchline. But here's the kicker. Attention mechanisms let the model focus on the most critical words. In the sentence, "The lecture was extremely engaging but too long." The model zeroes in on extremely and too long to balance the sentiment. Finally, a sigmoid function turns the model's output into a probability, like a confidence score between 0 and 1. If it's above 0.5, it's positive. Below, it's negative. This is how AI doesn't just read text, it understands it. And that's just the beginning. Stay tuned for more deep dives into the future of AI.